Okay, so chapter 9 is the advanced array concepts. And this is just an extension of chapter 8. Last time we learned about, the single dimensional arrays or 1D arrays. In this chapter, we'll be dealing with the 2D arrays or the multi-dimensional arrays. We'll also be going through the bubble sort and insertion sort algorithms. These are just two of the many algorithms out there that you can use to sort arrays. And that is one of the things about arrays, is you can sort them. There are also some built-in functions. I'll show you what those are. But if you don't have that option, because not every program or language has that option, so you can sort it by using different methods. Okay, and we're just doing two because those are the two easier ones and easier to understand. But there are several of them out there, and not all of them are, I mean, they have their own advantages and disadvantages. But we'll see how these two work in this this class. We'll also be doing two-dimensional arrays and multi-dimensional arrays. Ragged arrays is another thing. We'll cover that as well. The array class, let me just type that in there. Array list, a lot of typos in here. And enumerations. Okay, so let's talk about sorting or swapping elements. And this is, this early computer science, or actually for the students who are really beginners, this was actually a challenge for them to swap these two values. So you have two elements here, or two items here for n1, n2, and if you want to swap, n2 and n1, how would you do it? Okay, so the idea was that, I could just say, n2 is equal to n1, and that would do it. No, if you do that, then basically you're removing one of the variables, the values, and now both would be just either 3 or 5, right? So you lose one of the other values. So the way to do this is to introduce a third or a temporary variable to store one of those values, and then you can do this. You can use a swap. Okay, it's a really common feature in computer science to do this, and also a process when you do in the bubble sort, you need to do the swapping. So this swap is a process how you do it. It's a step-by-step process how you do that, and the term algorithm means it's a step-by-step process how to solve any problem. Okay, so sometimes you have to think it out, maybe write it down on paper, or draw things out and see how you solve that particular problem, and that is the algorithm. Okay, so in this example here, you cannot just say n1 is now n2, and I swap them. Well, you can't. You basically just reassigning n2 to n1. So now both will be story number 3, right? So to do that, you need to introduce this temp variable called temp, or whatever you call it, and that will store one of the values, either n2 or n1. And then you can do the swapping, and then you can swap the temp back into the n2 in this case. So now both values will be swapped. Okay, and then you can toss out the temp after that if you don't need it. But you do need a third variable. Otherwise, it's impossible to do it. Okay. So this becomes a very common feature. So usually when you do this, you can actually write a function to swap. So instead of doing this manually like this, n times, just write a method, just a swap, and you pass in 2 parameters, and then they'll be swapped for you. Okay, it's easier that way. So sorting arrays. Again, arrays is there are collections of data, right, with identical data types in Java, and then usually in arrays, usually what you do is that you sort them out, because otherwise it will be kind of odd to have things unsorted. Of course, there's certain cases you might not want to sort them. Like for example, if you want to have an array to store data for maybe movie reviews, right? Each movie might have different data types, so you don't want to sort them, because if you do that, you might mess up the data for the movie types. So if you do sort an array, you also want to make sure that you also sort the other arrays so that they match up the index. But typically, arrays needs to be sorted, right? And then so when you sort an array, you have to determine or find out which methods to do that. Okay, so the question is, when do we determine, or when do we say an array is sorted? So this is the question here. Okay, so for every array, and this is true for every array in computer science, an array is sorted if the following is true. Again, back to math. If you don't like math, well, you can't escape from math in computer science. So again, this notation just means for all, or for every I that is less than j, that's the index, such that a of I, the a sub I, okay, is less than or equal to a sub j. This is the value of a, meaning that a is the array. Okay, so every element in there will be sorted this way, so that the current index of I is, with the value of ai, is less than the value of aj, which is 1 above it. Okay, if that is true, then the entire array is sorted. Okay, and so here are some examples of that. So this is the array. This is for case insensitive, so you don't care about the case. In this case, this will be sorted because A through Z, right? If you do care about the case, then this will be sorted because capital A comes before, uppercase comes before lowercase because of the Unicode, okay? So this is like 65 versus 97 for A. So that's sorted if you care about case. And then, of course, numbers will be sorted this way. Okay, this will be like sorted in the ascending order. You can also sort it using the other direction as well. The descending order will be the opposite of this. Okay, so by default in Java, and I think most languages as well, empty arrays or arrays with a single element, these are called singleton arrays. Okay, if here a singleton array is just an array with one element in there. And then an empty array is with 0 elements. Okay, so the length will be 0, whereas the singleton elements is length of 1. So as an example of those arrays, we have array of 0, right? You can do that. You can say 0. I mean, and this is kind of, there's no reason to do that here, but just to show that you can do this, 0, put a 0 in there. So with 0, you can't really store anything, right? Just empty. Another way to do that is just put nothing in the curly braces here, and that's also an array of 0. Okay, 0 elements. And then the singletons will be the ones that has only one value in there, so one element in there as well. Okay, either just one number or one true or one false or whatever it is. Okay. Some examples of how you might want to use this is, let's just say if you're reading a data from a text file from a database. Okay, you don't know how many elements in that database table or in the text file, and you want to store those data into your array, right? How do you know the index? Well, you don't, right? You don't. So usually, you will create an array such as, maybe you do something like int, and then if it's a string, maybe a string like string, let's just say text, and you don't know the array length. So you will read the text file into a variable, maybe int temp or t is equal to that whatever that text file is, and that could be, or you can maybe even read it from the input. You can say how long do you want this array to be, right? So you read that value from the input or from a text file, and if you type in 0, then down here, so I could say here read input, right? Read from input, and you read that from the input, and if you enter 5, then you can create an array of 5 elements. So in your code, you would do like because this is I didn't define the size. So after I read that size, I can now say this text array is now new string of t, right? So whatever the input may be, you would set that array text to be that size of t, and t could be 0, right? So if you enter 0, then you have 0 size. If you put 100, then it will be 100 size, right? Based on the input. So once that is done, then you need to check the length of the array. If it's 0, then therefore there's no data coming through. If it's more than 0, then there's some data. Okay, so this is one of the scenarios where you might want to check if the array is empty or not. Okay. But if you know already that you need to create 10 elements, then there's no point of saying empty set. Because as you know, once you set it like this or like this, you can't change the length later on, right? That's it. You are done there. That's for arrays. Okay, so sorting algorithms. So I mean, throughout the years, computer scientists developed several methods. This is in a complete list of the sorts. It could be more. Maybe you can even create your own someday. Okay, but these are the ones that have been created, and they're commonly used in applications. We're not going to go through all of them, but the first two in blue here will be explored in this class. Okay, so the bubble sort, insertion sort, selection, you have merge, quick sort, heap sort. This is very advanced here. You have counting sort and so on. So when you sort, and in terms of sorting, there's always the measurement of performance, right? So which one is better, which is quicker? When do you use bubble sort versus merge sort or insertion sort or selection sort? Which one do you use? And these are set by certain type of calculations. We call this the big O notation. It's a mathematical calculation to determine what's the fastest way to sort an array based on certain conditions. Okay, it's not always the best. Like bubble sort is not always the best, and you know, a quick sort may sound quick, but it's not always the best. It's dependent on the conditions. Like for example, the size of the array, right? If it's too big, then it may not be, you know, efficient for bubble sort. A different method will be more efficient. If the data are so dispersed across the array, that means that it's has some pre-sorted elements and therefore not really sorted. They may not be, you know, sufficient for bubble sort. Okay, or whether or not the array is completely sorted or not, right? So it depends on certain conditions. And so we explore these two, I should say not three, but two. The bubble sort and the insertion sort. Okay, so bubble sort is probably the simplest methods to learn, and that's why it's always introduced in intro to computer science courses. So if you look at this array here, have about 6 elements, and they're not sorted, right? So we can determine the length of the array by using the length property. Again, this is not a method, it's the length property of the array, and that will give us 6. Okay, and then the complexity again here determines how efficient bubble sort is. It says it's always it's O to the n of 2. Okay, O. The n means O means like the operations, how many comparisons go through each loop. The n is the number of elements. So in this case, we have 6 elements, and then to the power of 2. So if you do this in the, you know, 4 or 5 elements is not a big deal, but if you're talking about like 100 or 1,000 elements, then when you do the math calculation, it actually comes down to n to the power 2 times. Okay, so if you have times of iterations or operations. And again, I'm not going to go into details about the big O notation, but you can read more about it here, or you can even Google it. But the complexity for bubble sort is O to the n of 2. Okay, that means if you have 10 elements, then it's 10 to the power 2 times of comparisons in the worst case. Because if it's not sorted, that means you have to sort every element in there that many times. Okay. So here is the algorithm for sorting a bubble using the bubble sort. Again, a bubble sort means you, depending on which one you want to sort, you sort based on the smallest first or the large one first. Okay, so you look at the array here from 101 to 12. In this case, if you want to sort the smallest one first, then you want to move 12 to the far left, right? So instantly, initially you're going to have like the effect of 12 is bubbling up the array or bubbling down, either way you want to say it. So that's why it's called the bubble sort. So the first thing you do is you pick the first two elements, this A0 and A1, and you compare those two. So you can say if A1 is less than A0, or A0 is greater than A1, then therefore is not sorted, then you swap those two. Okay, so back to the swapping method we talked about. So you need to have a temporary variable to store one of those values so you can swap the two. You can't just say A0 becomes A2, A1. You would lose the other data, right? So you swap those two. If they're already in order, then you just ignore it, and then you move to the next one. So now look at A1. A sub 1, compare this to A sub 2. Okay, if A1 is bigger than the other one, then swap it. Otherwise, you keep moving on until the end of the list. Okay, so by the time you're done with this, you'll probably do a n minus 1 times when you do the comparison here, right? You compare n minus 1 times because you have 1, 2, 3, 4, 5, 6 elements here. That's n is 6. First, you swap these two. That's 1. Second, you swap this. That's 2, and then 3, right? And then 4, and then finally 5, right? So the 6th one you don't swap anymore because it's already the last one. So it's always n minus 1 times when you swap them. Okay, so that's how you sort. And with that said, so this is the code, one of the codes. Okay, there are probably several methods, but this is the common syntax or code to or algorithms to solve this sorting method using the bubble sort. Okay, so we have the array here, the one we just saw earlier, and we need to know the length of the array. So instead of saying a1.length in here, you should always use a variable to store that, so it's easier to see. Okay, and then I also created a temp here to do the swapping. Okay, so the first thing is you loop through each of those elements from j. I make j as the first one here of 0 to the total length minus 1. Remember, we're not going to swap the last one because that's already the last element, so we only check from 0 to n minus 1. Okay, and so from the 0, and then we set another variable for I because you need to check the next adjacent element in there. Okay, so you swap, so you need two index subscripts to do this. One is for the counting, and the other I is for the actual index, and you swap the two. Okay, so again, you set the array. You're going to loop through entire array here, n minus 1 times, and then you're going to loop through each of those index, and then compare the value of those. Okay, again through n minus 1 times. So a of I, which is in this case would be 0. If it's greater than a of I plus 1, which is the first one, right? A1, same thing. If that is true, then you want to swap them. In this case, it's not true because this is smaller than this already, so we don't do the swap. We skip it. Then we go to the I is not 1, so we look at this one here. Okay, so and then now we compare a of I, which is this one here, with the ai plus 1 with this one here now. So we compare these two. Is a of I greater than ai plus 1? No, so therefore we don't do anything. Again, we move to the next one. So the third time now I is now at this point, and then a of I is 213 greater than a of I plus 1. Yes, it is. If that's the case, then we put a of I, which is 213, into the temp. Okay, and then we swap this two. We just put a of I now holds the a of I plus 1, which is 108, and then the 108 position here, we swap that to the temp, which is 213. Okay, and then you move on to the next one, and we keep going down the list. So we do that for each of this comparison, and then once we do the first iteration, then we move to the second iteration. So now j is 1, and then we do that like 5 times. Okay, so as you can see, it's like 5 times here, and then 5 times here. So that's like 5 times 5, which is n to the power 2, right? Okay, in the big picture. So if you look at that same example here, so again, I'm not going to do the whole thing here, just to show you can trace this in your own time. But if you look at this, we're swapping the first two here. So the current array is this. We check the first two, 101 and 201 at J0 and then I0. If the first one is bigger than the second one, we swap. Otherwise, do nothing. So we don't do anything here. Compare the second two. J is still 0. Okay, the first iteration. So we're moving I along here. So now we compare these two. They're okay. No need to swap. Then we compare the next two here. So 213 and the 108 is it matched that condition because A of I is larger than AI plus 1. So we swap those two and we get 108 and 213. Okay, and then we compare these two here, and no swapping needed. So we here, and then finally we compare these two, and then we swap those two because 12 is smaller. So we got that through the first iteration. Okay, so the final array will look like this after the first loop through it. So when J0 is done, the array looks like this. So now we do one more time again when J equals 1. So from this, we repeat the whole process, J n minus 1 times. So J1 by the end of that time will look like that, and the when J is 2, if you follow these two, you see that the entire array will be sorted when we do J equals 4 times n minus 1. Okay. So it will look like that. And this is the other method. This one here, if you want to sort the largest first, not largest first. Yeah, right. So largest first, but you move the largest to the end of the array. So what we did was we moved the smallest one to the front, right? As you can see, each iteration we're moving the 12 closer and closer to the front. So here, so for example, previously 12 was like way over here, and then we're moving the 12 smallest going this way, and then each loop we move the next smallest this way to the left. So it takes much longer, or seems like more takes more effort to do that. Okay, so you have the smallest numbers bubble up to the top front of the array. This method here, you do the opposite. You will bubble, so the largest number will be bubble up to the end of the array. Okay, so you look at each array and you compare the two here. So if 101 and 201, which is bigger, right? So this one's bigger, so we keep that there, do nothing, and then we compare these two, 201 and 213. Oh, 213 is still bigger, so we do nothing there. Compare the next one, 213, 108. Okay, this is 213 is bigger, so you swap those two, and then now 213 is here, and then we compare this 213 against 556. You do nothing, and then you swap. You go here and then swap the next two, and eventually through the first loop, you see that the 566, the largest one, has bubbled up to the end of the array, right? So once that is there, you don't need to check that anymore. You can reduce that array by 1. So now I only check from this to this part. I know that array, that's the largest one. Okay, you do the same iteration here, and eventually 213 is going to bubble up to the second largest, like you see in green here. So when you do this through the entire array, then everything is sorted. Okay, so this is the different method to do it. You can bubble up the larger one first to the end, or you can bubble up the smallest ones to the left of the array. Okay. And again, the idea here is that for this one, when we want to bubble out the largest number, we start from the largest of the array, which is from over here, right, 6. When J is 6, and then we decrement down, you go in the opposite direction. And then now we limit I to J, right? whereas before we limit I just to the length of the array itself. So the first loop through j is, so initially it was j is 6, so when say when I is 1 through 6, or actually 5 because j minus 1, and then eventually it's going to get shorter and shorter because through each loop j is going to go 5 and then 4 and then 3, so the inner loop here gets shorter and shorter. Okay, so you don't do it like 5 times for each element, but you decrement that each time by 1. Okay, so this is actually more efficient. But the swapping is the same. This one is the same. The only difference is what I put in blue here. If you compare this to the other one, you see the difference. Okay. The other one is that we go from 0 and then to j is less than the maximum length. You plus the j. And then you say I is less to the maximum length as well, minus 1. Okay. So that's the bubble sort. So we can see. Any questions on the bubble sort before we move on? Do you want to see an example, or are we good with the examples I have there? Okay. Okay. Yeah, we'll come back and do some example, but let's go to the next one here, the insertion sort. This one here also has O to the n of 2, just like the bubble sort. That means so they both are equally efficient. Okay. This one is a little bit different. This one you would go through each element and then you compare this element to the previous elements. Okay. And then you would sort it based on the value. So if you want to sort through this array in the ascending order, then the first thing you want to do is you want to set, this is just a pseudo code here, you want to start from the first element, okay, well, I mean I have 1, notice it's not 0, you start from 1, okay, because you know array of 1 or 0 is always sorted already, so you need to worry about that. That means you have to have more than 2 elements in the array to sort. Okay, if it's just 1 element, it's already sorted, so we don't need to do that. So you always start with the second element, and then from there to the end of the array. And then you need to have a temp variable to store this value here, which is 2, so you know what you're comparing to. And then you need to set another variable to hold the previous element here, which is 0, or it says I minus 1, right? So I is 1 here, so I minus 1 is 0, so j is actually 0 here. So now I'm going to point this and this to compare those two. And then we do a loop in here, another inner loop here to do the swapping. This inner loop here is responsible for just doing from here to the left of the array. Okay, so you do them from there to the left, because you want to insert the smallest one as far as possible to the left or in its order. Okay, so we look at 2 here, and then if j is not less than 0, right? I mean, if it's 0, then we're already at the end of the array. We're done with sorting. So j is 0, so it is greater than or equal to 0, that's true. And the a of j, which is a of 0 here, is greater than x, which is x we say is 2. If that is true, then we go into the loop. In this case, it's true, right? Because 8 is bigger than 2, so we do the swapping again. Okay, so this is the pseudocode. I'm going to write into the code here so you can see what it looks like. Same array. So I still need to know the length of that. I need to get look at the current element. The current element I'm looking at, again, for insertion, you always start with the second element. If there's no second element, then the array is sorted. You don't need to do any further. So typically you want to check first if the length is more than 2. Otherwise you're done. I will assume that there's more than 2 elements in here. And then I need to do an index for the check. So this one will be the index that will be moving to the left of that array. I'll start at the first position, the first index, which is 2 here again. And I'm going to loop through the entire array here. So I'll set my current element to be a of I, which is a of 1, which in this case is 2. And then I set my index, my current index, my check index to be I minus 1, which is 0. It's pointing at this index here. And then now I say if the index is greater or equal to 0, I is 0, that's true. And the a of 0, which is 8, greater than the current element, which is 2, right? We just saw that's true. Then I'm going to swap the second element, which is a index of plus 1, replace that with the a of 0. So I basically moving 2 to the 0 position. And then I decrement my index and moving to the left of that, so now becomes minus 1. Okay, initially it was 0, but now we do a minus 1. So when I do that, I come back to the loop. The index is no longer greater than or equal to 0. It's minus 1, so therefore this whole thing is false. And it exits out of the loop. Then I replace my index, which is the second element here, with the temp. Let's see, is it right? My current is 2. My index of index, which is 0 plus 1 is 1, is equal to 8. And then 2. Yeah, so that's right. So that's the swapping. Okay, so again, you need this temp here. So this would be like a temp variable to store the current value of 2, because I wish, we'll probably want to trace this later. So again, the first is 2. Okay, I check it, and when I do the swap here, notice that a index of check index plus 1, because a check index is initially 0 here, okay, plus 1 now is a of 1, it's pointing at this position here, the 2. I replace that with the a of 0, which is 8. So now after I run through this while loop, this becomes 8. Okay, so the 2 is gone. That's why you need to temp set that here, so the 2 is still being held at this element called current element. And so when I come out of this while loop, then the index of index plus 1, which is again when I decrement this, it goes to minus 1. Okay, the first one through. So because minus 1, therefore this case is false, exits out, and then the index of minus 1 plus 1 is really the index of 0. And I replace that with the current element, which is 2. So 2 goes back in here. Okay, so you do that for every element, and then you move to the next loop, and then now I look at the j of 2, and now 4 goes in here, and the whole process starts again. Okay, so that's the insertion loop. So you're inserting the array this way. So when you get to something like this, to the 3, you got to move, compare this to the previous one, and you swap those 2, and then 3 is here now, and then 3 will be compared to 4. It's smaller than 4, so you swap it again, and then 3 will be over here. Okay, so at that point, you check the previous one, and then is no longer true, so therefore it's in that correct position, so it's sorted in that position. Then you move on to the next one. Okay, so this is the insertion sort. Okay, so we do the bubble sort, insertion sort. You just make sure you know the algorithm, because I mean, I don't know if there's a different algorithm. This is probably only one. I mean, there could be like you know, different ways you can kind of tweak this, but the logic is still the same. Okay, you still have to check one of the elements, and then you check the rest. You point at that current element, and you swap it with the previous elements before that current element. Okay, so this is the insertion source. You will insert 3 into the correct spot. So if you look at down this diagram here, you see the first thing is we look at it 2 and 8, and 2 is smaller than 8, so we swap this 2. And then now it's sorted, there's no more element. Now we look at the third one, which is 4. 4 is less than 8, so we swap this 2. And then 4 is now already greater than 2, so it's already sorted in that position. Okay, so 9 is already sorted, so we don't need to do that. Okay, and then we move to the 3, so 3 will be compared to 9, and then we swap the 9 to 3, and then compare to the 8, swap those 2, compare with the 4, swap those 2, and eventually you get to that position between 2 and 4. Okay, and then 6, you do the same thing. Swap that with 9, swap 8, and eventually you get it to a sorted array. Okay, so that's the insertion sort. Okay, so I'm not going to go into examples to doing this. I already have the code here, so you can copy this code and run it in your own time and see how it works. But these are the syntax, the algorithms to solve those two scenarios there. Okay, when I ask you an exam, the difference between the two, so you just make sure you know what the algorithm looks like. Okay, but I do want to talk more about the multi-dimensional arrays. So this is probably we'll spend more time doing this one here. So a n-dimensional arrays is basically just like any three-dimensional or n-dimensional matrices. So far you've only done single array, single dimensional arrays. I should put here 1D, right? One-dimensional arrays. But Java supports multi-dimensional arrays as well. And the most common one is the two-dimensional arrays. And pretty much every language you go there, you learn. Okay, because once you get beyond this, it gets complicated. Okay, so you can do a three-dimensional array, or use 3 subscripts, and it gets complicated because you have the x, the y, and the z. And usually you use that for game development, like 3D games. Okay, so you get the x location, the y position, and the depth of that image of the object. So that's common in game developments. But in terms of just applications, usually two-dimensional arrays. And these are some other names that you might hear as matrix, a table, a spreadsheet. Okay, but an array is nothing more than an array of arrays. Okay, so that's the term also to describe the two-dimensional arrays. So if you look at this table here, it's a 3x3 table or matrix, and of course they all have to have the same data type. You cannot mix and match them as well unless they're objects. Then of course it's going to be all objects, but the actual data itself in the array elements will still be the same type. So if it's object, then they're all objects. If it's string, then they're all strings, and so on. Okay. So the 2D arrays are indexed by 2 subscripts. The first one is always the row. The second is always the column. Okay. So when I ask you an exam, what is the length of the array here in terms of the column? What is the column size? Okay. Make sure you are doing the second index and not the first index. Okay. So this is the way how you declare 2D arrays. You just put 2 pairs of square brackets in there next to each other. So the first bracket is the row. The second bracket contains the column. And I don't know why I keep typing this as R. So this is, you just declare an array that references a 2D array of data type, whatever that data type is. This one here, so to use it, you have to use the new again, right? So new, the size. And this one here, if you declare an array of n by n matrix, I should put m here, because it could be a different column. So the rows and the columns don't have to be the same, but usually, mostly arrays have the same number of size for the rows and columns. I mean, not rows, but for the columns. Okay, so for example, here I have 3 arrays, 1, 2, and 3. You have each of those arrays. This is the 1D arrays have these values in there, and then to create a 2-dimensional arrays, I could now say the array called numbers is composed of 2 arrays, 2-dimensional, and then each of this inner part here, like the 1 here, right? But it's not a 1, it's an array. It's another array. So that's the first element. You separate by the comma here. To the next element is another array 2, and so on. You do it this way. You can separate out into separate arrays and do it this way if it's not confusing, or you can just write out this way in one line of code. Okay, and this is pretty common as well. So you can see this is the first row. You could have it in a single line like this, but it's much easier to see this way. So you can see the rows and columns just like a table. Okay, so we have this is a 3 by 3. So 1 row, 2nd row, 3rd row. I have an extra 3rd row. Okay, the column will be going down this way. So 1, 4, 7. That's first column. 2, 5, 8, 3, 6, 9, and so on. So it's a 3 by 3. Okay. And so if you want to do another example, I mean, how you reference it is by using the index subscripts for those rows and columns. So the 0 here, 0, 0 is referring to the first box, will be, in this case, be like this number, for example. It's in the 0 row and the 0 column, okay? And then 0 row, first column, right? 0 row, 3rd column, 0 4th column, and so on. Okay, so that's how you reference it. Here's a better example here. It's a 3 by 4 array. Has some data in there. So the first row has these values here. Okay, so you can use this, like, for example, movies and reviewers and so on, whatever you call it. So the first element here, the first index is always the row, and then the second is the column. So you want to grab the value of 4 here. You refer to the row of 0, and then the index column of 0 to get 4. Okay, so row 0, column 2 is this one here, so you get a value of 2. Okay, so just make sure that you do row first and then column first. But I mean, that's the standard way. But because these arrays are just variable, just numbers, you can actually sometimes you can swap the 2 here and you get a different result. So be careful when you do this one here. I'll show you some example later on. Okay, so before I do some demos, the size of the 2D arrays. We know that if we do array.length, we get the size of that array. Okay, if you do array.length, doesn't matter whether this is a 2-dimensional or 3-dimensional or n-dimensional, you always get the size of that row only. Okay, so array.length gives you the number of rows. To get the number of columns here, like this example, how do I get the number 4 here is you have to pick one of the row numbers. So in this case, you have equal number of columns, right? You have 4 columns, and then equal length. So the first column has 3 elements, second has 3, and so on, so they're equal. Sometimes they're not equal, so you might want to check. But usually if they're equal, then you can pick any row number here, and then you can do the dot length to get the total column. So here you say array of 0, the first element or the first row, and then give me the length of that will give you the number of columns. Okay, And if they are the same column size, then it doesn't matter what this is. It could be 5 or 3, whatever, as long as as long as it's part of the row index. Okay. So let's do a simple example in that two-dimensional array. We'll come back to that later. Okay, I'm creating a new project. This will be unit 9. Let's create a class. We'll just call this multi-array have a main method. Okay. So, I mean, the same rules apply to two-dimensional arrays. You can use a class as a data type or object, right? But so you can have, like, for example, to have a int type of two-dimensional array is you put a two pair of brackets here, and then followed by the variable name, numbers, and then you can do a new int, and then supply those variable indexes. So I could do a 2 by 3. Okay, so it's a 2 by 3, 2 rows and 3 columns. If you want to do a 3 by 3, how would you do it? 3, 3, right? Okay, so you just change that 3, 3. Okay, so two-dimensional. Well, let's see. So int here we have num1, num is equal to int, a new int. Right, so one-dimensional, two-dimensional. What do you think three-dimensional looks like? Yeah, 3 brackets, 3 pairs of brackets. Okay, so it's just like int like that. And then numbers, let's say try or something. I don't know. 3D. And then new int. 1, 2, 2, 2. I think that's it, right? So let's take x, y, and z coordinates. So 4th dimension, you keep going, that gets pretty long. It gets complicated, really complicated. So usually you stop at here, and again, you probably really you find a 3-dimensional array in most applications. But it's still usable in 3D because you might map it to, you know, let's just say, in terms of a big application like a business or a location here in Racine, in the state of Wisconsin, in America, right? It's a three-dimensional array. So the first index would be the city, the state, the country. Okay, you can do that, so you can map it so you get a cube. It's a cube of data, and this is really useful in terms of big data. Okay, but typically we'll stop at the two-dimensional arrays. So I'll just show you how you can declare n dimension of arrays in Java. So let's remove that one for now. Don't need that. So the numbers, when I set that to 2 by 3, then I can now assign those values. So the first will be 0, 0, and then if I put that to like 12, so that first box, the top left box of the table will store the value of 12, right? And so you can see it gets, I could do this like 1, so it's a 2 by 3, so that's 1, 2, right? And then I do this like 3 times, like that. 2 because 0, 1, and then Well, it's just 2 by 3. Is that right? Two by 3. No, that's right. You need 3 of them. Sorry. Even it's confusing. So you have 0, 0, 0, 0, 1, 0, 2. And then 1, 0, 1, 1. And then 1, 2. And this could be like different numbers, right? 2, 35. And then we have like maybe like 13, 31, 25, and 2. So that's my matrix. It's a 2 by 3 table. And to print them out, you will just reference again the same index for the column and the row. Okay, so again, I'm going to use my shortcut last time. So public static void. Let's put O here. Then object obj. And then system out.print obj toString. Okay, so I can print it in here. So now, if you want to print the first element here, the first box, you would just say O of numbers of 0, 0, right? That should print the number 12. Okay? And if you want to run this, you can press run or press Control 11. Control F11 for short to run it. And we get 12 because that is the first element of the box. Top left. So to
the print statement on the bottom.
Oh, here?
I mean, I would think that the print statement would be before the O numbers, O.
Oh, this one here?
Yeah.
Oh, it could be anywhere as long as it's in the class space. Yeah, I could put here. I could put above here. It's a method.
It doesn't matter.
Mm-mm. Yeah, it could be anywhere. So, I mean, that's how we do it, manually, right? So typically you want to loop through the array to print that out. So you can use a loop to print it out. So remember that this is a two-dimensional array, so you need to track those two in, subscripts. So to print it out, you need two loops. So the first for loop will be the I and the J, or row column. I usually typically just call it I and J, but when you get to something really complex, and if it gets too confusing, you want to say rows and column. Okay, it makes more sense that way. So the first one is going to be the row. Set that to 0. And then row will be less than or equal to, again, the length of the row, right? So how do we know what the length is? And I mentioned that the length will be just the numbers dot length. And we can do that in here. We can just say int row length is equal to numbers dot length. That's the row length. And since the columns are equal size, because they're both 3, so we know that that's 3 already. But if you don't know that, right? So you want to say int length is equal to numbers of any of those, usually the sub-0, and then get the length of that. Okay, this is the number of elements in the column, the size of the column. Okay, so now I can say row is less than the row length, and then row plus plus, right? That's my outer loop. That's for the row, and then now I need to go through the column. So the first one will be row 0, row 0, row 0, and then row 1, and so on. Okay, so the inner loop will be similar, except we iterate through the column. So int column is equal to, starting from column 0, which is right here. That's and then we must check for column is less than or equal to, or actually less than the column length. Okay, in this case it will be 3. We know that because we say 3. And then we have the column plus plus. Okay, and then now we just move this inside the loop to print it out. And we replace this by row and column. Okay? So if I print it out, it will be like kind of just a bunch of numbers because I didn't format this. So typically you would say maybe like put a space here. Okay, so this is the value of that column, which is 12. And then you print the 12 out and there's a space and then next numbers and so on. Okay? So if you run this now, you have the array printed in that order. And if you want this to look like a table, then after each of this inner loop, you want to do a print line, right? So it will break off right here, and this will move down to the next row, right? So you could say, like, for example, after this, you want to print O, and then put the /n here, force a new line, and if you run it again, see that it looks like a table. Okay? So that's how you loop through the arrays, two-dimensional arrays, to print everything out. You need to track the index for the row and the index for the column. So if I ask you to print not by row first, by column first, how will this change? So I'm printing like 2 rows and 3 columns. What if I don't print like print the column first and then the row? So if you do the opposite, you get a different result. Okay, if I swap these 2 here, and just copy this again and put it down here, right? So again, the first is always the row, but because we can do this, it still be the rows and columns, but the way we do this is also causes the output to be different. So if I change this to like column instead, right? So we do a column. So we swap this 2 here, and then this would be a row instead. What do you think the output's going to look like? Let's see. See if that works. We'll put another O here so we can know. O, like that. Okay, so we know that's the second matrix. If you run it now, see it looks different, right? Should put it in here. /n. Run again. So you have like 2 rows and 3 columns versus 3 rows and 2 columns. Okay, so the result looks different. So just make sure when you iterate through your array, which one you want to print out first. Because either one will work. You get all the results of the data come out, but the output is very different from what you may expect. Okay. So that's the for loop to print out the arrays. You can also use the for each loop. That's also can be done, but that's a little bit confusing. But it's all can be done. So now, what else do we need to do here? Okay, so we did this by initializing this using this method here. Instead of doing this, you could do this way, right? We comment this out, and instead of doing this, I'm gonna let me copy. Well, let's use the num here. No, let's just copy this. Copy it here, and turn off that second one, and this one we'll just put it equals, and we'll do it this way. Okay, so you can initialize it this way, and again it's usually easier to put it into different lines. So the first row is going to be, 12, 42, 35. Doesn't matter what, it's just some arbitrary numbers. Then you go with the second row. I'm just going to copy what I have here. 31, 25, and 2. Okay, that's by 2. That's my 2 by 3 array. It looks the same. I can see it's much shorter than doing this way, right? Very short. And if I print this out, I should get the same output as I had earlier. So if you print it out, it should still have the same result as before. Okay, because the array is still the same. Or if you want, you could say, I want to have, different. Sometimes it gets complicated, so you may even, break this into separate arrays. And then you just put the array name in here. So I could say, I could take this out and put it up here, and a single dimension array, A1 equals that, right? Equals that, those values. And I can copy this, A2 and A3. Well, actually, only have 2. So A2 will have these values here. And then in here, I'll replace these with the array name, A1, and then A2. Actually, no, I mean without the braces. Okay, because the braces is already part of the array. So now it gets just like that. Easier this way. So I have my array of arrays. Okay, if you do this way, sometimes it's easier to manage. Okay. All right. So any questions on this? We good with two-dimensional arrays? Notice that I've created 2 arrays here. They are both equal length, right? They have both 3 elements here. So these become the columns. Each of these elements becomes the columns. Each array becomes the rows. Okay, so it's two rows and then 3 columns. Okay, if you add another one, they will have 3 rows and then still by 3 columns. If you increase the elements here, you're increasing the rows, the column size for that as well. Now the next topic here is what is it? It's the ragged array. And why don't we take a little break? We'll come back and then we'll continue with this one here to the next part. Okay, so let's take a 10-minute break and come back, and we'll continue with the ragged arrays.